Hi everyone. So last seminar lesson, we explored the linear regression. In this seminar lesson, we're gonna learn how to do the linear regression inference, okay, or doing hypothesis testing. All right. Okay, so again, we're gonna start with the example. In 1905, R.J. Gladstone conducted a study of the relation of brain to the size of the head. So the brain weight in grams and the head size in cubic centimeters measurement was performed for 237 adults. Use a 1% significant level. Let me highlight that. So use 1% significant level. This means alpha equal 1%. To access if there is a significant positive linear relationship, right? I want to know if there is a significant positive linear relationship, maybe highlight in blue, significant positive linear relationship between brain weight and head size. That will be your alternative hypothesis, right? So before that, let me show you the steps for hypothesis test. So the first thing first, you have to determine the null and the alternative hypothesis and set the alpha. Remember, the alpha here is 1%, right? So how do I determine the null and alternative hypothesis? There are three choices for you, right? For the null hypothesis, beta 1 is always equal to 0. By the way, beta 1 represent the population slope. Okay, beta 1 represent the population slope. All right. However, for the alternative hypothesis, you have three different choices, right? Either beta 1 is greater than 0, meaning you have a positive linear relationship. Beta 1 less than 0, meaning you have a negative linear relationship. Or beta 1 is not equal to 0. It means significant linear relationship. When you see this, when you see if it not equal to 0, that means you have two-sided test. Two-sided test. And for the other one, for this one, oh, sorry. For this one, maybe I highlight in blue. This and this is one-sided test. Okay. These are one-sided tests. Either beta bigger or less than 0. All right, so back to our problem. Which one will you choose? Remember what I highlighted. I highlighted in blue right there. Significant. I want to know if there is a significant positive linear relationship, right? Positive relationship. So the very first choice, right? The very first choice, right? So so we choose that. So using 1% significant level, we want to access if there is a significant positive linear relationship between the brain weight and the head size for all adults in 1905. Okay, so H naught is beta 1 equals 0. That's always equality for the null hypothesis. Versus the alternative hypothesis, HA, is beta 1 is greater than 0 because of this, right? That's what we want to know. Where beta 1 represents the population average change in brain weight for each additional cubic centimeter in head size. Okay, so this is the interpretation of beta 1. A lot of times your instructor will not require this, but it's nice to know how to explain it and explain beta 1 in words, right? Okay, step number 2, the assumption, right? The assumption. Remember here, 4 steps. Step number 2, assumption. So step number 1, we done. Step number 2, assumption. Okay. Number 2 is assumption. So there are 3 assumptions that require that you need to satisfy. First, the population relationship is in fact linear. Second, the true errors are normally distributed. Third, the true errors have constant variance. Okay, so how do I show these the assumption actually satisfy the problem? For the first and third, for this one and this one, we're gonna use the plot called the residuals versus fitted plot. Okay, again, this is going to be generated for you, right? It's cumbersome to do by hand, so it's going to be generated for you. So what you're looking for is what you're looking for is your all the dots, all the residual here has to be randomized, right? We like to see a random scatter of the points with a roughly horizontal band center around 0. So that little red dash band there, that's proven, that show that the true error have a constant variance. Right? The red one is show you that your true error have a constant variance. Errors mean residual. That little e. And the population relationship is in fact linear. How do I show that? All the point is, all maybe I'll do in blue here. All the point is randomized. See, all the have the random scatter of the points. Okay, so that means it shows that the population relationship is in fact linear. Right. Now, how do I show the? So that's 2 out of 3. Now, how do I show this one? How do I show? Oops. Sorry about that. How do I show is the true error normally distributed? Well, if you want to show something normal, all you have to do is either you set up a histogram or the scatter plot, right? Whichever one. Right here, right? You can use a QQ plot. We can use QQ plot. I'm sorry, did I say scatter plot? I'm sorry. If you want to show something that normal or not, you want to set up either histogram or QQ plot. Right? So here you want to set up a QQ plot of the residual, right? To see if the residual follow a straight line with a positive slope. By the way, for the second step, the assumption, a lot of professor not looking, doesn't really go into this. I explain a lot, but just for your information. However, the maximum they would do is they ask you to list out the 3 assumptions, and that's it. You don't have to do anything else. Here, I actually show you how to show that, how to prove, there's no proven statistic, but prove that these requirements are satisfied. Okay, but a lot of times the professors just ask you to list out all these three without showing anything else. Right. Okay, now step 3 and 4 is we state the observed value of test statistic, the corresponding p-value, and your decision. Right. So what is your test statistic? And then from test statistic, you figure out your p-value. And from p-value, you can compare with the alpha. Remember, the alpha is 1%. And then you draw your decision from there. Okay. If p-value is less than alpha, then we reject the H0, meaning we favor HA. When we favor HA, what does that mean? We favor, I mean, we say that there is a significant positive linear relationship between brain size and head circumference, right? And if p-value is bigger than the alpha, if p-value is bigger than 1%, then we fail to reject H0, meaning we favor H0. Well, remember what's H0? H0 is beta 1 equals 0. So that means there's no significant linear, positive linear relationship between brain size and head circumference. Right. Okay, so but first of all, let's figure out how to figure out the test statistic. Right. There are 2 test statistics that you can look into, either t-test or f-test. Right. Now here is, I'm showing you the R software. Again, different instructors showing different things. Some people use StatsDisk, some people use Excel, or some instructors just straight give it to you, right? So here in the use R software, the t-value here, right here, this is your t-value. The t-value is 20.08, right? And its corresponding p-value is very small, right? If you see e minus 16, that means 10 to the negative 16. So this is 2e negative 16 means 2 times 10 to the negative 16. So that's a very small, like 0.0000016 times, right? So it's very small, it's a very small p-value. Now, this p-value is the two-sided p-value, two-sided p-value. Notice that, two-sided. Why? Because of this. Oops, sorry. Right here. See that? Two-sided p-value. Okay, so the F-test statistic, here's the F-test statistic difference. The number is different, but that's okay. Its corresponding p-value is pretty close. It's pretty close to the t-test, right? These two very close. Usually they're very close, right? Now, which one do I choose? Do I choose to use t-test or do I choose to use F-test, right? Here, I'll show you how which one to choose. If your alternative hypothesis HA is two-sided, we can report either t-test or F-test. If it's two-sided, remember what two-sided mean? Back, two-sided mean what? Beta 1 is not equal to 0. This implies two-sided test. Remember I write it before? I write it in the beginning. I believe I did. Right there, two-sided test, right? I write at the beginning, two-sided test. So if alternative hypothesis is two-sided test, then we can report either t-test or f-test. If it's one-sided test, then we can only report t-test statistic, right? If it's one-sided, then use t. If it's two-sided, use you can use either t or f. Don't matter. You can choose whichever you like. Right? Why can't we use f when it's one-sided? Because the f distribution is a positive distribution, right? It's strictly positive, so we cannot divide it by 2. Well, you don't have to get into that. Okay, so now remember, let's go back to our HA, right? Our alternative hypothesis. Remember, our alternative hypothesis is beta 1 is greater than 0. This means is one-sided test, right? It's one-sided test. If it's one-sided test, we're going to use the t-test statistics. So we're going to use the t-value. Right? So the t-value here is 20.08. Here, t-value is 20.08. And the p-value, corresponding p-value is the tiny ones, 2 times 10 to the negative 16. And again, what I said before, this is two-sided. This is two-sided, right? Two-sided. So we have to divide it by 2. Remember, our test is only one-sided. So we have to split the p-value in 2, which is, it's still small, right? It's still small, which is what? This is like 1 times 10 to the negative 16. Still very small. It is definitely less than 1%, right? It definitely less than, what's 1% is 0.01, right? If it's less than what I said about when p-value is less than alpha, if p-value less than alpha, we reject H naught. Like we reject H naught. So the decision is we reject H naught. And we say that there is a positive linear, there is a positive linear relationship between head size or brain size, maybe let me say brain size and head circumference. Head circumference. Okay.